So before I start off the video, I wanted to make a little update. So Kryptonite Tech, my favorite subscriber, asked for me to make a series about PIC microcontrollers, and I actually have one, but it's an outdated one. It's the 16F 505, PIC 16F 505, and I couldn't really figure out how to use it. I wrote some code to blink an LED and programmed it with my programmer that I showed in the last video, and it didn't work. So it's either broken or I just can't figure out how to use it because it's like super outdated. So I'm gonna try to get a newer one in soon, and I'll start a video series about that. So stay tuned, Kryptonite Tech. But in this video, I actually wanted to go over making different types of logic gates with NAND gates. And in the beginning, I want to show you guys basically how you would make two kind of simpler ones. So over here is how you would make a NOT gate. So basically, if you tie the two inputs of the NAND gate together, you get a NOT gate, and that's pretty much simple because anytime that the two inputs are the same on a NAND gate, you get kind of this inverted output. So if you have a 0 on each input of a NAND gate, you get a 1, and if you have a 1 on each input of a NAND gate, you get a 0. So that's basically what that does. And to make an AND gate, basically you would take one NAND gate and connect its output to this NOT gate, because basically over here you have NAND, and then if you NOT something that's already knotted, you get what was originally there, which is AND. So these are pretty simple, but in this one I wanted to basically make an exclusive OR gate, and on Google, if you Google it, there's all types of schematics on how to do it, but I kind of wanted to come up with my own way. So my way was make an OR gate, check if the two inputs of the OR gate are 1, basically an exclusivity bit, and then AND those two signals together to make sure that you don't have two inputs that are 1, or else do the OR output. So to start off, to make the OR gate part, which is part 1, you basically are going to have two inverters, and the outputs of those two inverters goes into a NAND gate. And over here I wrote out some proofs that this works, but we don't really need to go over it, as you know, I'll show you it works at the end of the video. And you know, we get the truth table of an OR gate. So that's not being close to done, that's about half done. So now in part 2 is where we do this thing I call exclusivity bit. So you know, exclusive OR, you know, the first 3 are of the truth table are basically the same as an OR gate, except that when both inputs are 1, you get a 0 on the output, because it's exclusive. You can't have both being 1. It's one or the other. So the way you do that is you just NAND your original inputs that you had in the first part. So you would basically want to NAND these two inputs, because on a NAND gate, if both inputs are 1, you get a 0. So that does this part. Okay, so when you do that part, you can basically move on to the last part, which is taking that output and ANDing it. So again, as I just said in the last part, this output would go to a NAND gate, and then the actual OR bit, or the OR gate's output, which is this, would be NANDed with this exclusivity bit, and then you'd want to knot that so you could AND them together. Okay, and you could basically see I wrote a little equation to make it a little clearer, but basically the simplest thing I could say is you want to AND the OR, and you want to also AND it with that exclusivity, because you want this last part of the truth table. So I'll show you on the breadboard. I built it up in advance, and I used two 7400 quad input NAND gates, but I'm only using 6 of them. And you could see if I bring, you know, one of them both of them to 0, it's off, and then one of them to 1, it's on, one of them to 1, it's on. But then you get that exclusive OR behavior when I bring them both high, you see that it's off. So that follows the truth table pretty well. And yeah, and to make an exclusive NOR gate, you would just have to look at the output that's over here. So basically, we could take this wire off. And what's over here is an exclusive NOR. So you could see that the exclusive NOR is just going to be the opposite of exclusive OR. So when they're both 1, it'll be a 1. And if you have 1, 0, it'll be a 0. Okay, and then you have 0, 1, it'll also be a 0. But if you have 0, 0, it'll be a 1. Because it's just completely the opposite of exclusive OR. So yeah, in this video we basically made every type of logic gate with just NAND gates. And if you guys like that video, stay tuned for more. And as I said in the beginning, I will be making more videos about the PIC microcontroller once I get a newer one, because this one that I have lying around is kind of hard to use. And yeah, and stay tuned also for the 6502 series. I'll be making more videos about that. As you guys saw, I added a hexadecimal output to it. So I'll go into actually using like an assembler to actually make machine code for it. And yeah, so just stay tuned guys for more videos. They're coming soon. I hope you guys enjoyed this video, and I'll see you guys next time in the next video.